All right, so for Algebra 2, the thing we're going to be going to now is SAT problems. All right, so this first worksheet that you guys are going to get, I'm going to go over three of them, right? I think there was 8 problems, so I'm going to go over 1, 3, and 8 for you guys, and then you guys have to do the rest on your own, all right? So this first one, all right, this first one here. A bag contains 7 blue marbles, 14 marbles that are not blue. Whenever you're doing problems like this and they ask you what's the probability, the thing you want to remember is it's always going to be the total, all right? What is the total? And then the numerator is what are they talking about, all right? So in this case they're talking about probability that the marble is blue, all right? So the number of blue marbles. All right, that's all we have to do for these type of problems. These problems should be simple. These are the ones that you should get correct right away. Don't even waste a lot of time on them. All right. So to figure out the total, we have 7 and 14. All right. So 7 plus 14 gives me 21. All right. So we know what the total is. Let me erase this mess. All right. So we have 21. So the probability, sorry, my writing so bad. The probability that the marble is going to be blue, all right, is going to equal, well, they said that how many blue marbles did we start off with? We started off with 7 blue marbles. What was the total? We do some simple damn arithmetic. 7 plus 14 gives me 21. All right. So then reduce, you can divide both of these by 7. So we end up with 1 over 3. So what's the probability? We always have to reduce. All right, guys? I don't care what type of damn fraction problem you're doing. You come across a fraction, make sure it's reduced. All right? So what's the probability of that you pull out a marble? 1 out of 3. There's a probability. All right. This third one. Should I say number 3? I'm sorry. So number 3. All right. Now instead of marbles, they're talking about jelly beans. Same damn problem, right? It's the same exact kind of problem. So again, we're looking for the total. All right. So we're looking for the total. All right. So when you do the total, you don't have to write this crap down. Just add up all the damn all the numbers. So 20 plus 45 plus 30. There's 30 orange jelly beans, and then 5 cotton candy jelly beans. So our total is going to be, 20 plus 30 gives me 50. 45 plus 5 gives me 50. So there's going to be 100. All right. So we know it's going to be something. So the probability, and I didn't even finish reading the problem. All right. If you reach in the bag to grab a jelly bean, what's the probability that it'll be a watermelon? All right. So what's the probability that it's going to be a watermelon jelly bean? Well, the total was 100. How many watermelon? There was 20 watermelon. And again, we always reduce. All right, you always reduce. You can divide both of these by 20, or let your calculator do the work for you. So what's the probability? 1 out of 5 is the probability of grabbing a watermelon jelly bean. All right, number 8. Number 8. This is one of those problems that you guys like to skip because it's a lot of damn reading. All right, don't don't start getting yourself all worked up about it. Go figure out what is it they're asking. All right, go figure out what the hell they're asking you to do. So we look at it. If the alarm sounds for a customer, and especially problems like this that give you a chart, I'm not even going to look at, to begin with, I'm not even going to look at that mess. I'm not even going to look at that mess to begin with. I might have to go back and read it, but to start off, I'm not even, what the hell? All right, to start off, I'm not even going to read that stuff. They give me a chart. So if the alarm sounds for a customer, what is the probability that the customer did not attempt to shoplift. All right. So what am I looking for? I'm looking for, oh, come on. I'm looking for the probability that did not steal. All right. That a customer didn't, oh, crap, if I can spell. All right. That a customer didn't steal. That's what you're looking for. Probability that a customer didn't steal. All right. Well, where do you see that a customer did not steal? All right. So it says, what is the probability of customer if the alarm sounds? All right. So if the alarm sounds, this is all we're looking at. We're looking at that right there. That's all we're looking at. I don't give a crap what any of that stuff is, because what does it say? If the alarm sounds. The rest of this mess over here doesn't even matter. Doesn't even matter. Okay. So if the alarm sounds, so that's all I'm worried about is just that first column. So what do we know? The denominator has to be the total. Well, what was the total for the alarm sounding? The total was 56. All right, remember, that's going to be the total. And in this case, it was for the alarm sounding, which was 56. All right. And then, what does it say? What is the probability a customer did not attempt to shoplift? All right. The customer did not attempt. All right. So that customer is not trying to steal. Well, which one is it? It's right there. Oh, crap. All right. Try to be a little neater about this mess. All right. There's the one right there. So which one is that going to be? That's going to be 35. So what's the, all right? So this one didn't steal. All right. Didn't steal anything. Well, in this case, you can divide both of them. You can divide both of them by 7. All right. Divide both of them by 7, and you'll end up with 5/8. But if I'd have been paying attention, all these answers are in decimal. So I actually did a little bit too much work. All right. Didn't even have to think about it. Grab your calculator. All right. Grab your calculator. Do 35 divided by, oops, crap. Divided by 56. All right. So then with your calculator, you'll get, oh, it's not even approximate. It's going to be an exact. All right. That one's going to be exactly 0.625. All right. So what's the answer? The answer is D. 0.625. All right. All right, so hopefully that helps you guys a little bit. Hopefully that helps when you look at a really big, ugly problem like this. All right, you guys start looking at all these words and you say, "Oh, screw that! I'm just going to skip it." Go read the problem. Go read the question first. What are they asking? Especially if you're given a chart. All right. Hope that helps.